Okay, Assalamualaikum and hi. This is my video for the x86 segment 1 programming environment. So I have already opened the SASM and loaded the file average4.asm. First, I will build the program to make sure there are no errors. So I will just go here, build this. Built successfully. And now I will start the debugger. So I will go to debug and debug. Okay, so as you can see, now the green arrow is on the first line of instruction. So this means the program is ready to be executed step by step. Okay, so now I will open the memory window. So as you can see here, it's already open because before this I have to do some try and error. And here, when there is no memory, this memory table present, you can just go to debug and tick the show memory. Okay, so in the memory windows, I will first add the array data, and for this one I will just choose hex, and for this I will choose W forward, and array size I will write 4. So as you can see, there is 4 values here. So, and the next one is the result. Okay, so for this one also I will just choose hex, and this is W, and the array size is 1. Okay, so now as you can see on the data, there is 4 values, and the result is currently 0 because the program has not stored anything yet as of now, because as you can see here on the line 7, we haven't done any instructions yet. So now I will open the CPU registers window. So as you can see on my right hand side, so if these are not present, so you can just go to debug and show registers, and it will just pop up like this. So in this window, we can see registers such as EAX, ECX, EDX, and ESI. So I will focus on these registers while stepping through the program. So from now on, I will just use debug and step over each time I say step over. Also, I can just you can also use the F10 to step over into the next line. Okay, so I will now execute the program 1 instruction at a time using step over. So the first instructions being sub EAX. So when I click step over, okay, so for this one, as you can see, the register EAX becomes 0. This clears the accumulator before we do any calculations. Okay, so for the next instructions is MOV ECX 0x04. So after I click step over, now the register ECX have become 4. This value will be used as the loop counter for the 4 elements in the array. So as you can see here, there are 4 values, 1, 2, 3, and 4. Okay, so the next instructions is MOV ESI and 0x08. Okay, so when I click step over, now the ESI is set to 8, and these registers will be used as an offset to access the elements in the array. So right now we are in the AW loop to summing the array. So now we are here in the loop. So I will continue to click step over and observe the changes in the registers and memory. Okay, so the first instructions is the ESI decreases ESI by 1. So just now the original value is 8. So it changes the decrement SI is by 1 because we have already executed this line, DEC ESI. So when I click step over, we can see that ESI becomes smaller, and as you see after I executed the loop several times, you can see that the ESI value will keep on become smaller and smaller. So again, I will just step over. Okay, so now the ESI value is decreased by one more, so it moved back by 2 bytes in total after executing 2 lines of instructions, 13 and 14. Okay, so the next instruction being add AX DS data plus ESI. Okay, so when I click step over, okay, here the value from the array data at the address data plus ESI is added into EAX, as you can see here. Okay, so we can see that before this the EAX value is 0, so this means we are accumulating the sum of the array. So the next instructions is loop AW. So when I click step over, okay, so this decreases ECX by 1. If ECX is not 0, the program jumps back to AW and repeats the loop. So as you can see here, before this it's a 4, so it decrement by 1. So now we will do the next loop, the next cycle of loop, until it becomes 0. So while ECX decreases, okay, so I will just go through the loop again until it becomes 0. So wait, so it already became 2, 1 and 0. So when I continue to click step over several times, each loop adds another element from data into AX, which ECX decreases from 4 until it becomes 0. So after 4 iterations, AX contains the total sum of all 4 elements. So now the loop have finished. So now after loop finish, the program prepares to calculate the average, and the next instructions is sub EDX. So when I click step over, okay, so this clears EDX to 0. So before this, there is some certain values here. So when we want to calculate the average, the EDX value need to be 0. So hence this line of instructions rewrite the EDX into the 0 values. Okay, so now we are on the line MOV CX 0x04. So when I click step over, now the ECX have become 4, which is the number of elements in the array and the divisor. So when the instructions div CX divides by AX, which is 4, when I click step over, okay, so as you can see here, the EAX now contains the average after we have divided by 4. Okay, so finally we are on the MOV DS result EX. Okay, so this line of instructions stores the average into results. So when I click, okay, so before that, as you can see now, result is 0. So when I click step over, okay, so now we can see the result in the memory window change from 0 to a new hex value. So this is the average of the array. So okay, for the bonus task, I will print the result to the output window using the print hex macro, this one. So in my code, I added the line print hex to result after storing the result and before exiting. Okay, so at first the program printed correctly but showed a crash message after. This happened because the old exit using int 0x80 which is not compatible with the SASM's mode. So I fixed it by exiting normally using RET. So the ending part of my program is now here. This is the whole new things that I have already added. So it becomes like this. This prints the average and ends the program without crashing. Okay, so when I execute the print hex, as you can see in the output here, we can see the average printed in hexadecimal, which is 2800. So the program ends normally without any crash message. So this completes task 1. So before that, I will just go through this. Okay, so now the debugging have already finished. So in conclusion, I have already used SASM to debug the assembly program step by step. So I showed the memory and registers, observed how the sum was accumulated, computed the average and stored it into a result, and printed it using print hex for bonus marks. So that is all from me. Thank you.